بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. Let us continue solve more exercises about section 7.4 rational functions, integral of rational functions using partial fractions. Here we need to evaluate this integral. The degree of the numerator is 2, the degree of the denominator is 4. It's okay. We call it proper rational function. I have irreducible quadratic factor in the denominator. Raised to the power 2 means it's repeated. So x squared plus x plus 1 over x squared plus 1 to the power 2 can be written as ax plus b over x squared plus 1 plus cx plus d over x squared plus 1 to the power 2. And now I need to find a, b, c, and d, and I cannot use our quick method, so we have to multiply. I have to multiply both sides by the LCD, which is x squared plus 1 to the power 2, the original denominator. If I multiply the left-hand side, all the denominator will disappear. And now, multiplying the first term, this term, by x squared plus 1 square, x squared plus 1 will be cancelled with one of these two, and I'll have ax plus b times x squared plus 1. For cx plus d, when I multiply, the denominator will be cancelled. Nice. So I will have the following. I can expand this. I have ax cubed plus bx squared plus ax plus b plus cx plus d. Now compare the coefficients. The coefficient of x cubed is 0 in the left-hand side, so a is 0. The coefficient of x squared is 1 in the left-hand side, so b is 1. Now the coefficient of x is 1, and the coefficient of x here is a plus c. So a plus c is 1. But a is 0, so c is 1. Now the constant term is b plus d in the right-hand side. In the left-hand side, it is 1. But b is 1, so d is 0. And now I will be written as ax plus b. A is 0, b is 1, so I have 1 over x squared plus 1 dx plus. What is c? c is 1, so I have x. d is 0, so that's it, over x squared plus 1 to the power 2 dx. These two integrals are easy and you should find them immediately. Integral of this is tan inverse x, and here you can solve it by substitution. You can take u equals x squared plus 1, du would be t 2x dx, so you need 2 here and half here, and 2x dx would be du, so you'll have du over u square. And integral of u square is -1 over u to the power -2, u to the power -1 over -1, or -1 over u, or -half times 1 over u is x squared plus 1 plus c, and that's the answer. Degree 3, degree 4, proper rational function. Let me take x squared as a common factor. I'll have x squared plus 6, and here the denominator. So x squared linear factor repeated twice, x squared plus 6 is an irreducible quadratic factor. I can find b, only b, using our method by canceling x squared and replacing x here in the left hand side by 0. So I'll have -2 over 6. So b is -1 over 3. And now I have to multiply by the LCD. The LCD is x squared times x squared plus 6. So when I multiply by the LCD, I will get x cubed plus 6x minus 2 equals a times x will be cancelled with x, and I'll have another x times x squared plus 6. b is -1 over 3. X squared cancels with x squared, and I'll have x squared plus 6. cx plus d will be multiplied by x squared, because x squared plus 6 would be cancelled. All right, let us expand and move 1 over 3x squared plus 6 to the other side. So I will have x cubed plus 6x minus 2 plus 1 over 3x squared plus 1 over 3 times 6, that's 2. And here I will have a times x squared is x cubed. So ax cubed plus x times 6, 6x times a, 6ax plus cx cubed plus dx squared. Very nice. 2 cancels with 2. And now, what is the coefficient of x cubed in the left-hand side? 1. What is the coefficient of x cubed in the right-hand side? A plus c. Good. What is the coefficient of x squared in the left-hand side? 1 over 3. What is the coefficient of x squared in the right-hand side? D. Good. The coefficient of x is 6 in the left-hand side and 6a in the right-hand side. So a is 1. And if a is 1, then c is 0. So I would be equal to a is 1, so 1 over x. The second, -1 over 3 over x squared. C is 0, D is 1 over 3. So plus 1 over 3 integral 1 over x squared plus x. So the answer would be ln absolute value of x minus 1 over 3. This is x to the power negative 2. The integral would be minus, so it would be plus over 1 over x plus 1 over 3. This integral would be tan inverse 1 over square root of 6 tan inverse x over square root of 6 plus c, and that's the answer. You can write it 3 square root of 6 in one fraction. Now make a substitution to express the integral as a rational function and then evaluate the integral. Well, we mentioned the substitution is you take u as the root and then you change from x to u. So this would be u, but what about x? So I need to raise both sides to the power 2. Then x is u squared plus 1. And dx would be the derivative of u squared 2u du. So the integral would be dx is 2u du. X is u squared plus 1 times square root of x minus 1 is u. And I will write it here. But u cancels with u. And I will have 2 over u squared plus 1 du. Wow, that's easy. Square root of 1 over u squared plus 1 is tan inverse u plus c. And u is a square root of x minus 1. So that's the final answer. Here, make a substitution. Well, the substitution here is to take u as e to the power x. If I take u equals e to the power x, du would be ex dx. Notice that e to the power 2x is e to the power x all squared. So this integral would be e to the power x is u, and the other e to the power x, because this is e to the power x times e to the power x, with the dx is du. This is e to the power x squared, so it is u squared 3u plus 2. And I can write it as, or let me call it I, and let me work now with u over u squared plus 3u plus 2. I can factor. Okay, u plus 1 times u plus 2. And I can write it as a over u plus 2 plus b over u plus 1. And I can find a by canceling u plus 2 and replacing u by negative 2. Negative 2, negative 2 plus 1 is negative 1, so a is 2. And I can find b by canceling u plus 1 and replacing u with negative 1. Negative 1 plus 2 is 1, so b is negative 1. And this integral would be integral of 2 over u plus 2 minus 1 over u plus 1. And the answer would be 2 ln u plus 2 minus ln u plus 1. And the final answer would be 2 ln u is ex. So that's the answer. If you want to uh, write this as a single logarithm, you can. I will leave it like this. Similar questions. Here, u is cosine x. Why? Because du would be negative sine x dx, and we already have sine x in the numerator. So I would be equal to negative sine x dx is just du. Cosine x square is u square. Cosine is u, and it's changed to u. Now 1 over u square minus 3u, if I take u as a common factor, I will have two linear factors. I can find a by cancelling u and replacing u by 0. I can find b by cancelling u minus 3 and replace u by 3. So the answer would be negative 1 over 3 integral 1 over u plus 1 over 3 integral 1 over u minus 3. So negative 1 over 3 ln absolute value of u. And what was u? Cosine x. That's it. That's the answer. What do you think should we take as u? You should now understand the method. If you take u tan x, du would be secant square x dx, and this is what we have in the numerator, and the integral I would be, well, t, okay, just t, tan t secant square t dt. Secant square t dt is du. Tan square t is u square plus 3u plus 2. And then can you factor this? And can you write it as, and can you find A and B and continue the question? Please, exercise for you, an easy exercise. Here, I take U as what? Sinh T. What is du? Cosh T dt. So I would be what? Cosh T dt is du. Sinh square is u square plus u to the power 4. So 1 over, take u square as a common factor. Well, I have a over u, b over u square, cu plus d over the irreducible quadratic factor. I can find b, isn't it? B, canceling u square, replacing u by 0, b is 1. That's good. And now let me multiply by the LCD, which is u squared times 1 plus u squared. A times, before A, the left-hand side is 1. A times u times 1 plus u squared. B is 1 times 1 plus u squared times u squared. Well, I have here a u plus a u cube. 1 is cancelled with this one, and u square, I take it to the other side, so it's negative u square. And here I have cu cube and du square. Compare the coefficients. A plus c is the coefficient of u cube, and it should be 0 because there is no u cube in the left-hand side. The coefficient of u square is d, and the coefficient of u square in the left-hand side is negative 1. A should be 0 because there is no u in the left-hand side to the power 1. If A is 0, then also C is 0. So A is 0 and C is 0. That's nice. So the integral would be equal to A0 finished. B is 1, so integral 1 over u square. C is 0, D is negative 1, so negative 1 over integral of u square plus 1 du. Of course, you can continue. And don't forget to write u as sinh t at the end. That's it. Thank you very much. I hope you enjoyed partial fractions.